Today, we're diving into what a lot of experts are calling the single most important skill for the 21st century. And it's something most of us, well, we were never really taught in school. We're talking about complex problem solving. Let's get right into it. So let me just ask you this straight up. If you had to pick one skill to really master for the future, what would it be? Researchers have been wrestling with this, and they keep landing on the same idea. It's not so much about what you know, but about how you figure things out when there's no instruction manual. You can just feel it, right? The world's changing. All those routine, predictable jobs are getting automated. And the really big challenges, we're talking social, economic, environmental, they're just getting messier and more tangled up. So the old skills, like just memorizing facts, they're still useful, sure, but they're not nearly enough anymore. We need something more flexible, a way of thinking that lets us tackle brand new situations. Okay, let's bring this down to earth. Think about the last time you got a new smartphone. There was no manual, was there? You just had to start tapping, swiping, exploring menus. Basically, you built a little mental map of how the thing works. That whole process, learning by doing, by just interacting with it, that's a perfect everyday snapshot of complex problem solving. In school, most of the problems we get are well-defined. Think of a math equation. There's a clear question, a clear set of steps, and one right answer. But the real world? It's just not like that. It's jam-packed with what are called ill-defined or even wicked problems. Things like figuring out climate change or navigating a business through a crisis. The goals are fuzzy, the rules keep changing, and there's definitely not one single right answer. So what is this thing really? What is complex problem solving, or CPS? It sounds like a buzzword, I know, but researchers have actually spent decades trying to break it down. So let's try to unpack the DNA of this super skill. All right, here's the textbook definition. It's about the successful interaction with complex systems. Now, the key word there is interaction. This isn't something you can just sit back and think your way through. You have to poke the system, see how it reacts, and then adjust your strategy. You have to act, then observe, then adapt. So what makes a problem truly complex? Well, it comes down to these 5 things. And the best way to understand them is to just think about being a university student. First, there's complexity. You've got way too many lecture notes, textbooks, and articles to possibly handle at once. Then there's connectivity. Everything's linked. You have to pass this course to unlock the next one. The system also has dynamics. Your own energy and motivation levels go up and down completely on their own. It's intransparent. You never know exactly what's going to be on the final exam. And finally, you've got polyvaluity, which is a fancy word for having multiple competing goals. You have to study, right? But you also want to see your friends, maybe work a job, and, sleep. That right there is a classic complex problem. Okay, but wait a minute. If this skill is so messy and unpredictable, how on earth do you actually test for it? How do you take something like that and turn it into cold, hard data you can compare? Well, in 2012, something pretty major happened. The PISA assessment, this huge international study that tests 15-year-olds all over the world, decided to start testing for this exact skill. And that was a huge deal. It was like officially putting CPS on the map as a core skill, right up there with reading, math, and science. And the results were pretty fascinating. You had countries like South Korea and Japan right at the top. But here's what was really interesting. Some countries, like Australia, did way better on this problem-solving test than you'd expect just from their regular math and science scores. It suggested that maybe, just maybe, their education system was teaching something more than just book smarts. So what did one of these tests actually look like? Well, it wasn't a bunch of multiple-choice questions. They were these little computer simulations, sometimes called micro-worlds. In this one, for example, a student gets to be the manager of a record label. They can play around with things like how much to spend on advertising or networking, and then they see how that affects sales. The whole point is to figure out the hidden rules of the system just by playing with it. But this leads us to the big debate, the twist in the story. In the effort to make a test that you can give to thousands of students, did we have to simplify the problem so much that it wasn't really complex anymore? Are we actually measuring the right thing? Let's just go back to this idea for a second. That record label simulation, at the end of the day, it's a well-defined problem. The rules are programmed in, there's a clear goal. But real-world problem solving, the stuff that really matters, is all about those ill-defined problems where everything is murky. And that difference right there is the heart of the whole debate. See, the early research back in the 70s and 80s used these ridiculously deep simulations. There was one famous one where you had to play the mayor of a simulated town and you were juggling over 2,000 different variables. Obviously, you can't put that on a mass-produced test. So instead, they developed what they call minimal complex systems, these streamlined versions with just a handful of variables. And that brings us to this powerful critique from one of the leading researchers in the field, Joachim Funk. He said, minimal complex systems run the danger of becoming minimal valid systems. In other words, in our rush to make a test that's neat and tidy, did we basically strip out the very complexity we were trying to measure in the first place? It's really the difference between what some people call little p problems and big P problems. Those PISA tests, they're little p problems. They're tidy. You can often crack them with a simple scientific approach called VOT8, which just means vary one thing at a time. But our world's biggest challenges, they're big P problems. They're wicked, interconnected monsters like pandemics or global economics. We're trying to change just one thing at a time as, well, it's totally useless. I absolutely love this quote from Tolstoy's War and Peace because it just nails the difference. Chess is a little p problem. It's incredibly complex, sure, but you know all the rules. You know how the knight moves. War, on the other hand, is a big P problem. It's all about uncertainty, chaos, and a million factors you can never fully know. The tests we have now, they're a lot more like chess than they are like war. So, where does all this leave us? Well, even if the tests aren't perfect, the skill itself is more critical than ever. And here is the absolute most important takeaway from all of this. This is not some fixed trait you're born with. It is a skill, and just like any other skill, you can actually train it. You can get better at it. And we've got proof. One study looked at students who did problem-based learning for just one term. Before and after, they tested their general problem-solving abilities. The result? Their scores jumped by 13%. And the control group who didn't get the training? No change at all. This stuff is teachable. So how do you actually improve? This is the good stuff. It isn't about having a genius IQ. It's about building habits. Good problem solvers, they practice staying calm when things get chaotic. They force themselves to keep an eye on the big picture. They think strategically instead of just reacting. They're constantly asking, okay, did that work? What should I try next? And most importantly, they stay mentally flexible, ready to ditch an idea that isn't working. These are the habits of mind that let you lead, innovate, and just be resilient. And all of this leaves us with one really big question for all of us to think about. As we rightly put more and more focus on teaching this vital skill, we have to ask ourselves, are we just preparing students to solve the tidy little p problems they'll find on a test? Or are we truly getting them ready for the messy, unpredictable, big P world that is actually waiting for them?